Hello, my name is Kevin Bauer, and today I'm doing my senior design project proposal. And my senior design project is energy savings analysis of the Mackenzie Residence Hall at Alfred State. And my senior project advisor is Professor John Owejan. So the first thing took a look at with planning out my senior project is an overview of the Mackenzie Residence Hall. And I got this picture from Google Maps. I broke it down into a few different sections, and the first sections that I'm going to be looking at are the 9 square sections that make up the majority of the student housing at the Mackenzie Residence Hall. And each section measures approximately 66 by 66 feet, and this was all done by the measurement tool on Google Maps. Next, I'm looking at 11 different rectangular sections that make up another part of the residence hall, and they measure approximately 47 by 40 feet. And there are 6 of these sections that are connected in sets of 2, and then there are 5 that stand alone by themselves. And then lastly, I'm taking a look at the commons area of the Mackenzie Residence Hall, and for the purpose of putting this into an energy analysis software, I simplified it to a square which measures approximately 125 by 135 feet. And all of those dimensions were found using the measuring tool on Google Maps, and more exact measurements will be found once the snow is off the ground at Alfred State, so it's much easier to get up there and measure. So to do the energy analysis of the residence hall, I'm going to be using eQuest Energy software, which is provided free of charge to any citizen in the United States through the United States Department of Energy. And there are a lot of different design characteristics that can be inputted on this software to be utilized in the energy analysis. And this can find both heating and cooling loads of the building. So a few different design characteristics are architectural design, any HVAC equipment that's installed in the building already, the building type and size, floor plan, construction material, the area that's actually being used inside the building, any lighting systems that are inside. And it can also look at your geographical location, the amount of sunlight that is coming to the building, the amount of time that you heat and cool the building, and the orientation, north, south, east, west, that the buildings are inputted. And I'll have to do multiple different analyses on eQuest due to the varying different arrangements of the different buildings of the Mackenzie complex. And we learned all about this system, all about the software in HVAC system design, where Professor Owejan walked us through an energy analysis of the engineering building at Alfred State. So my project is going to take a look at 3 different energy savings techniques that can be installed into the Mackenzie complex in order to reduce the energy footprint of the college campus as a whole. So the 3 techniques are drain water heat recovery, a plate heat exchanger, and an entropy wheel. And for each one, I'll do a new energy analysis using eQuest on the entirety of the Mackenzie complex. Along with the energy analysis, I'm going to be doing a cost analysis. And here are a few different aspects that will go into the cost analysis: the installation cost, the maintenance cost, total energy savings of each technique, any government tax incentives that are given to you for installing these energy saving technologies, the time to recuperate the initial investment, and the usable life of each technology. And this is really important to have a simplistic system, because the SLC, or Student Leadership Center at Alfred State, used to be a silver certified LEED building, but the systems put in place were hard to maintain and needed a high level of expertise in order to maintain them, so they actually bypassed those systems and lost the elitist certification for that building. So they need to be easy to maintain, easy to install, and pretty much anybody can maintain these systems. That's high importance, and we looked at that in our HVAC system design class. So the first technique I'm looking at is DWHR, which stands for Drain Water Heat Recovery. And the first technique I'm going to be looking at is drain water heat recovery. And the manufacturer of the drain water heat recovery I'll be using is Renewability Energy Incorporated, and they produce the power pipe. And this is just this is the only regular drain water heat recovery I could find widely available, and you can just buy it at Home Depot, and anybody can go out and buy it and put it in your own home. And it can reduce the home energy consumption by 5 to 10%, and that's just for a regular residential house. Next, they also put out that the efficiency is around 59% for this drain water heat recovery. And I contacted the company for more information, and they actually got back to me and they gave me some performance curves and efficiency curves that I'll be able to utilize as part of the project. And what drain water heat recovery does is it recovers the heat from any warm drain water you have, which would be through a shower, a dishwasher, or a washer, or just a regular clothes washer. And in the residence hall, it'd be used in all the showers and also all of the laundry machines, because there are a lot of times when the showers are just used one right after the other, and there's a high potential of heat recovery for that. The next technique I'm going to be looking at is plate heat exchangers. And there are a few reasons why I wanted to do a plate heat exchanger over any other type of heat exchanger. One of the reasons is it allows for expansion. Right now, the Mackenzie Residence Hall is going under a lot of renovations, and they need and they might retrofit in a different heating system, and this allows for expansion of that heating system. The plates are also easy to replace. If one gets broken, you can slide any of them off and replace that one very easily, and they're also easy to maintain and easy to clean. And I was looking at the manufacturer, Alfred, which produces small, medium, and large heat exchangers for any use. And we talked about all different types of heat exchangers in our heat transfer class, and that's where I got this information about why I chose a plate heat exchanger. And then the last type of energy savings would be an entropy wheel. And this is also known as a desiccant wheel or an energy recovery wheel. And what's unique about an entropy wheel that the other two techniques don't have is that they can be used in both summer and winter. And they are put in place in the ventilation air handler for the system, where you can pre-treat the incoming air before it goes and gets air conditioned for the building. And this allows heat and humidity to be transferred between the incoming and the outgoing air, all dependent on whether you want the inside air to be hotter than the outside air or colder than the outside air. And there are a wide variety of entropy wheels. They go from 60 cubic feet per minute up to 50,000 cubic feet per minute, so there are lots of different entropy wheels out there for any situation. And in fluid mechanics, I was able to do a lab project that dealt with the desiccant wheel dehumidifier, which had, the main part of that was an entropy wheel, and I got to learn a lot about them during that experience. And I got all of this information from heatexchange.com. And then here are a few key classes that I'm going to be using for my senior project, as well as basic engineering skills. So thank you for watching my senior project proposal, and if you have any further questions, please feel free to reach out. Have a nice day.